Minimum cost to merge the stones, we are given an array and a value of key. We have to merge key consecutive values, like we can merge 1 2 or we can merge 2 3. The cost of this merge is the summation of entire range. So the cost of this is 2 plus 1 3. The cost of this is 3 plus 3, which is 6. 6 plus the previous merging cost, which was 3, leads to 9. So this is an optimal solution. If we have chosen this path, 2 plus 3, which is 5, and then we have merged 1 plus 5, which is 11, right? Total 6 plus 5. So which is not an optimal path. So we have to reduce down the entire array to single value, and we have to return the minimum cost that we can achieve in order to reduce it down. Now there might be cases where you cannot reduce down, like there are 5 elements and the value of k is 4. So we can either merge these 4 consecutive or we can merge these 4, but it leads to only 2 values. We need at least 4 values to reduce down the array to 1. So it is not possible in this case, thus we return -1. Now one greedy solution, if we think about, would be to try out all possible merging cost for this scenario. The constraints are actually allowing that. The constraints are pretty small. So if we see 1 plus 5 is 6, here the cost is 8, here the cost is 5, and then 6. So we choose the minimum cost, which is 5. So we merge this. The current cost is 5. Then this is minimum. So the current cost becomes 6 plus 5, 11. Then we merge this, it becomes 20. And then when we merge this, it becomes 35, which leads to an optimal solution. So greedy actually works for a lot of cases, but I executed a greedy solution. And this is the test case on which it was failing. The greedy solution, the greedy answer, and the trying out all possible cases answer will be different for this test case. You can try it by yourself if you want to. Now this problem, if we talk about the similarity of the problem, it is kind of similar to matrix chain multiplication, where we can split at every index and we can determine the cost of the right subtree and the cost of left part, right? In that we also used to find the sequence of merging. What is the most optimal sequence and what is the minimum cost that we can achieve by using that sequence. So here, for trying out all possible cases, this is the core loop that we are going to use. I and j are basically the starting and the ending points. Like I is here, the start, and j is here. So the result is the minimum value of I to m and m plus 1 to j. We are doing the summation, minimum of result, that is the result variable. We'll see those things. But the cost is like, suppose you put a split on this one, right? So the minimum value would be the cost of this entire thing, which the recursion will tell us, right? And this thing. So we will sum the cost returned by this recursion call plus this recursion call, right? So I to m, suppose the value of m was I, right? We are starting the m with I. So m and I both are 0. The j is here. So the recursive cost of this merging and the cost of this entire thing. So we will add them up. It will lead to us entire array cost. And we have to find the minimum by trying it to every index. Now you will not be able to try it every index here. K is 2. That is why we can try it every index, because like we can try it here, then we can try it here, right? But suppose I'm just making some arbitrary numbers. Suppose the array value is 7 and the k value is 3. So you can perform like you can start splitting at this and this entire thing. Then you cannot split at here because you will not be able to, merge 1 and 5. This was a single cost and we would return one value from this entire right subpart and we would add this to our entire this value, which are consecutive. But if we reduce down to this to 2 value and you return only one value from this, right? So you will not be able to derive a single cost from this entire left part. So that is why we have to jump k minus 1 steps, that is 2 steps. So we can perform a split here, then we can perform a split here. This part which leads to one value and this part which will give us one value. Now how will this part give us one value? For this part we will also apply the same thing. We can also, for these four values, we can split at 2 and we can split here. So this 3 will get merged and will return one value, and that value will be added to this 2, which leads to again one value, and finally this entire thing that returned one value will be merged to this one value, merging 153, which is 9, right? So that is how it is working. So we have to jump basically k minus 1 steps. So here I've written m plus c equals to k minus 1. So this is how we will try all possible cases. Now one more thing to discuss is the failing case, like this case. When will we not be able to find a solution? So you can see we have to reduce down, if the size of the array is 5, we have to reduce down 4 values. We have to eliminate 4 values, right? So we have to eliminate how many values? N minus 1 values, where the size of the array is n. And we are given k. Now at every merge, these values reduces down by what value? They reduces down by k minus 1 values. Why? If you merge these 4 values, you will also, you remove these 4 values, but you also insert the cost of this value. So the total reduction is k minus 1 only, right? You reduced 3 elements from the array in one step, one operation. So basically you have to check n minus 1 modulo k minus 1. If this is 0, that means you can achieve the solution. If this is not true, you will not be able to achieve the solution. Okay. The second thing is prefix sum. Now the prefix sum is simply calculated like in the recursion, right? When we find this entire k consecutive values, now the cost of this would be 9, right? But to do that efficiently, we can just use a prefix array instead of an actual array, so that we can quickly get the answer, right? Reduce down some complexity. For prefix arrays, basically prefix array of this would be 1, 6. So we will add up all the values from the left hand side. Here it would be 9, 11, 15 and so on, right? So if we want to find the summation of these consecutive values, suppose the I pointer is here and the j pointer is here, what we do is array of j plus 1 minus array of I. J plus 1 is 11. Wait a second, we can do it like this: j minus I minus 1. Initial, we can add one more element to a prefix array, which is 0, right? So this 9 value minus the previous value. We can also use another approach if you want to do that j plus 1 thing. We cannot include the current element in the left sum. So this is 0, this is 1, this is 6 and so on. That is how we calculate the prefix sum, right? So this basically, this value represents the summation of only the left hand side part. That is why, right? So for that you can follow that previous formula, j plus 1 minus I, right? This is the entire recursive stack space you can follow, right? This is the thing that I explained you, the merge operation. And here is the code. Here is the exact same loop. Here is the edge case. If it is possible to merge, only then we will calculate the cost and we will return the cost. Similarly, here we are calculating the prefix sum. We can submit this.